Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Department of Artificial Intelligence and Data Science, B.V. Raju Institute of Technology, Narsapur campus. Today we will discuss about the introduction to machine learning. Before going to machine learning definition, what do you mean by learning? Learning is an ability to improve the behavior, based on the experience. Based on the experience means it is called as a past data. Based on the experience. Here the machine learning can be explore the some algorithms. What can explore means it can be learned from the data or build a model from the data. The second one is the model can be used for prediction. Prediction means can find out the outputs and decision making or solve the problems or tasks. Okay. Coming to the definition of machine learning. Here in the definition of machine learning, each different authors can be defined in different statements. Okay. For suppose the machine learning definition is it is an application of artificial intelligence and that can be provide the system with the ability to automatically learn, think and improve the experience without being the explicitly programmed, and also provide the systems with the ability to automatically learn and improve from the experience. That is the definition of machine learning. See once again, the machine learning is a application of artificial intelligence that provide the system with ability to automatically learn, think and improve from the experience. What is the meaning of these three statements? We can learn something based on the fast data, and think means what to do next. Okay, what to do next. After what to do next, we can creating the different models, and if after developing the models, if the model is not accurately, after that we can improve from the experience. Without being the explicitly programmed. See this diagram. You can collect the data from the different sources. The data will be assigning to the machine learning models. The machine learning model can be predict the data, learn from the experience and improve the experience. These are the different categories. That is the definition of machine learning. Here, what is the history of machine learning and how and when the machine learning will be start? Here, in 1952, Arthur Samuel can be developed one of the main program. That program is called as a playing checkers game. Playing checkers game means simply that is the chess game. Okay. Here in this chess game, we can observe the positions at the game and learn the model that the given gives the better moves for the machine player. In 1957, Rosenfeld can be proposed one model that is called as a perception. It is called as a simple neural network unit. After 1960s, the delta learning rules that can be used for the learning perceptions. What mean the role in the delta learning rules means it can be used for procedure for training the perceptions. It is also known as pattern recognition. The pattern recognition is one of the topic under the machine learning. Here 1970s, the machine learning can be following the symbolic type of artificial intelligence. artificial intelligence, and it can be good fashioned about the artificial intelligence. Okay, the J.R. curriculum can be developed in 1986. The decision tree learning can be developed. Decision tree learning can be developed. The decision tree learning is mainly focused on the ID3 algorithm. ID3 algorithm. This ID3 algorithm will be come under the construct the decision trees. That is the upcoming modules. The decision tree algorithm, most important algorithm in the machine learning algorithms. The coming to the ID3, there is a in that ID3 having the many alternative ID3s are developed. One of the main ID3 algorithms are CART algorithm. What is the meaning of CART algorithm is classification and regression testing. That is the regression trees. In the 1950s, the PCA can be machine learning can be statistics to develop the large extent. It can be during the SVM model, support vector model. In that 2000 year, the kernelized version can be developed. That is, the kernelized version is called as a SVM will be proposed. In the 2001, the ensemble models can be developed. Who can be developed? Bremen can be developed. It can be developed the multiple decision trees. Each decision tree having the random subset of instances. In 2005, the neural network will be developed. In the neural network, one of the most important domain is deep learning, and also forces the neural network with the many deep layers. In the neural network, there is a number of layers are there. First one is the input layer, second one is the hidden layer, and third one is output layer. These layers are many layers are under the deep learning concepts. In the 2009, the Google can be built one of the most important application is self-driving cars. In the 2001, Watson can be again developed in IBM. It can be one of the main popular game is called as a question and answers. In 2014, the human version can be surpassed by the machine learning system. Nowadays, the machine learning algorithms having the GPUs, which can be enabling the machine learning, and deep neural networks. There could be availability of the big data on the field of machine learning. This is the history of the machine learning. Coming to the what are the next one is what are the key components of machine learning? In the machine learning, there is a several key components are there. What are the key components? Means the first one is data, second one is model, third one is learning algorithm, fourth one is prediction and also called as a output, prediction or output. See one by one component. First one is data. Here in the machine learning algorithms or machine learning concept, it is the most foundation of machine learning. The data is a most foundation in the machine learning. Here the data is collected from the different sources and also used to train the model. Can collect the collection of data from the different sources and it can be used to train the model. Okay, this can be include the either labeled data. That labeled data is under the supervised learning algorithms. Unlabeled data is comes the unsupervised learning algorithm. Both are the machine learning algorithms. Okay, that is the data. The second one is model. In this machine learning, we can represent the mathematical representation. The model can be represent the mathematical representation. It can be make the predictions or decisions. can make the predictions or decisions based on the data. Predictions or decisions based on the data. For example, what type of the models are under the machine learning algorithms? Some models are there. First model is linear regression. Second one is the decision tree. The third one is the neural network. That is the second key component in the machine learning. The next one is algorithms, learning algorithm. After develop the model can perform the some algorithm, that is it can be process that they adjust the model parameters. These model parameters to fit the data and minimize the error. Some examples are called as gradient descent, stochastic gradient, and back propagation. These are algorithms under the deep learning concepts. Now coming to the predictions or output. After training the data, the model will be used to predict the outcome for a new unseen data. These are the four key components under the machine learning. Coming to the next one, what is the difference between the traditional programming as well as machine learning application? Here, simply the traditional programmings are like C, C++, Java. These are the traditional programs. What is the difference between these traditional programming and machine learning? Now see this one. Traditional programming, coming to the traditional programming, the user will be give the data to the computer as well as write the program through compiler. That both are sent to the computer. The computer can be perform the operations and give the output. Okay, give the output. That is the traditional programming. Well, coming to the machine learning, the user will be give the data to the computer and also give the outputs to the computer. The computer can be prepare the model and give the output. That is the difference between the traditional programming and machine learning. See this one by one differences. What the differences are coming to the traditional programming, what the differences are coming to the machine learning. See one by one. The first one is, in the traditional software, the main primary objective of traditional software is it can meet the functional and non-functional requirements. While coming to the machine learning, the primary goal is to optimize the some of the metrics. What the metrics are optimized? The metrics are accuracy, precision or recall, mean square error, and also F1 score. These are the different parameters or these are the different metrics under the machine learning. Okay, every 0.1% can be improve the model metrics, the result in the significant business value creations. Coming to the second difference is the quality of the software. The primary can be depends on the quality of the code. In the traditional software, the software is whether the quality is there, automatically the code will be quality. While coming to the machine learning, the quality of the model can be depends upon various parameters. What the parameters is this, which will be mainly related to the input data and hyperparameters tuning. That is the second difference. The coming to the third difference, the traditional software is created by using the one of the stack. The stack is called as a main and Java. The Java is a full stack. Well, coming to the machine learning models, can be create different algorithms and associated SIM libraries. In the machine learning algorithms, we are using this some libraries like Pandas, NumPy, sklearn. These are the different libraries can be used under the machine learning algorithm. Each of these algorithm will be different performance. The results will be different performance. That is the difference between the traditional programming and machine learning programming. Machine learning. Here, what is the flow chart of machine learning process? What the machine learning will be process? Here there is a different kind of steps are there. The first step is data collection. How to collect the data? The data will be collected from different resources. Different sources. After collecting the data, can perform the data pre-processing. Once you can collect the data from the different sources, the data is whether a raw data. After gathering the raw data, to remove the noises, from the data, after removing the noises from the data will be given to the model selected. In this step, can select the particular model. After selecting the model, the data will be given to the training and validation. The data will be split into two ways. The first way is training, the second way is validation. Some data will be given to the training, some data will be given to the validation. After giving the validation and the training, that is called as a next step is evaluation. In this evaluation, we are using this some parameters are there. What are the parameters? In previous slide will be discussed. F1 score, recall, accuracy, mean square error. These are the different evaluation metrics are using the machine learning concept. Finally, you can get the model. These are the flow chart of machine learning process. See one by one step. What is the first one is data collection. Here the first step is to gather the data that can be used to train the machine learning models. This data can be come from various sources. What the data will be collected from different sources like sensors, websites and databases or some logarithmics. That is the data collection. The second step is data preparation. Here, once the data will be collected, after collecting the data, can prepare the data to the model selection. What to do means, here the raw data can be raw data. The raw data can be contain noises, errors and irrelevant information. The data pre-processing can be involved cleaning the data, handling the missing values and transforming the failures into the usable format. That is called as a normalization techniques or scaling techniques. That is the data preparation. After the data preparation is completed, next comes under the model selection. Here different machine learning models are there. Each model can be perform different types of tasks. What type of the task will be performed the machine learning? What are the some examples are there? First one is regression and classification. These are the best examples of model task under the machine learning. Here the model can be select. The model will be select. It can be depend on the problem at hand. The problem can be hand. Here some examples are linear regression, decision tree and neural network. These are the different models will be selecting for the particular machine learning algorithm. Now coming to the training the model. The fourth step is training the model. The data can be split into training and testing sets. The data can be split into training and testing set. The training data is used to train the model by adjusting the parameters. So in this training the model, 20% or 30% or 40% data will be given to the training period. So remaining data will be given to the testing model, to testing the model and training the model. These are the depending upon the based on the adjusting parameters. That adjusting parameter is based on the input and corresponding the output. Corresponding the output, that is called as a label. That is the training model. Well, coming to the model evaluation. After training the model is tested on the unseen test data. Unseen test data to evaluate the how it can be generalize the new data. How analyze the new data. In this model evaluation, the main goal is to minimize the difference between the predicted and actual results. Difference between the predicted and actual results. Finally, final step is prediction. Once the model is trained, the model can be make the predictions on the new or unseen data. These are the flowchart and overview of the machine learning process. Next, one of the best example is predicting the house prices. This example is one of the supervised learning algorithm. Okay, supervised learning algorithm. All the parameters, all the steps, this predicting house prices can be performed different step-by-step methods. Okay, coming to the prediction house prices. Predicting the house prices is the supervised learning algorithm. The supervised learning algorithm can be involve the training model based on the labeled data. Here, the supervised learning algorithm is simply called as labeled data. The data with known as outputs. See the step-by-step process. Okay, for in this application, predicting the house prices application is there. What they are follow the step-by-step method. The first method is data collection. Okay, first of all, to collect the data about houses, what the parameters are available in the house, like just like a features, size of the room, number of rooms are there, what is the location of the room, and what is the price. Finally, you can get the what is the cost of that particular house. You can predict the cost of the house. So, predict the cost of the house means is called as a label. Okay. The second one is data preparation. Here, to clean the data set or removing the missing values and numerical values. Okay. The next step is model selection. Here, we can choose the model. The model is very, very important in the machine learning. So, choose the model. The model will be like either linear regression. Next one is model training. By using the portion of the data to train the model, where the model will be learn the relation between the features. What type of the features are that application? These two features are available in that application. Yeah, already I will discuss with here. Size and number of rooms and target price. That is the 4 steps. The next step is model evaluation. How to evaluate the model? The model will be evaluated based on the different evaluation metrics are there. Okay, evaluation metrics. For suppose one of the evaluation metric is mean squared error. Not only this one, there is a number of evaluation metrics are there. F1 score, accuracy, recall, precision, confusion matrix. These are the different evaluation metrics where we can evaluating the particular model. Finally, we can follow the prediction. By using the training model to predict the prices of new houses based on the features. What the features are given the input, like number of rooms, size of the rooms. These are the two features given to the input. This is the example of predicting the house prices. Okay. Now coming to the what the difference between the artificial intelligence, machine learning, deep learning as well as data science. What is the differences are there? There is a 4 concepts are very important in the machine learning, deep learning or data science. See, coming to the one by one, what the machine learning is there? Here the artificial intelligence is a science that can be enable the computer to think like humans. Computer to think like humans, just like a robotics. See this Venn diagram: artificial intelligence, machine learning, deep learning and data science. This is the entire role in the artificial intelligence. Machine learning is a subset of artificial intelligence. Deep learning is a subset of machine learning. And finally, data science is a whole part. That is the Venn diagram. Here, the artificial intelligence can be allows the computers to imitate the intelligence and do the things that human do. Artificial intelligence can make the decisions. A best example is buy or sells, understand the text, that is the read articles, and also see the detect faces. That is the artificial intelligence. What is the example? Now see this one example, beautiful example in the artificial intelligence. Here AI based algorithm is created the segregate the some fruits. Here the fruits is there in the box. The fruits will be put into the conveyor belt. Okay. Here the segregate the fruits by using the decision logic with the rule based engine. Decision logic based on the rule based engine. For suppose if the apple is on a conveyor, the apple is on a conveyor belt. The scanner would be scan the label. The scanner would be scan the label and informing the AI algorithm. In this example, what is the AI algorithm? Can give the AI algorithm that will be the fruit is apple fruit. Then the apple would be rooted in the apple fruit tray via sorting the rollers. Simply, the scanner will be scan the labels. After scanning, the AI algorithm will be given to the data to the robotics. The robot is pick the fruit and the fruit will be keep it to the some tray. That is the best example of artificial intelligence. The next one is machine learning. Here, the machine learning is a subfield of artificial intelligence that can be enable the machines to improve at the given task with the experience without using the explicitly program. One of the main important thing is the machine learning techniques are classified as a artificial intelligence. Here, some basic rules based algorithms could be classified as a artificial intelligence. Some basic rule based algorithm will be classified into artificial intelligence. Here in the machine learning, one of the beautiful definition is there. Here the what is the definition is the computer program that can learn from the experience E with respect to the task T and performance will be measured with the P. Experience is mentioned P, task will be called as a T and performance is measured with respect to the parameter P. So, if the performance at the task T, the performance is at the task T as measured by the performance, it can be improve the experience. It can be improve the experience. It can be improve the experience. Here the tasks, what type of the tasks are there? Predictions, classifications and acting. Here the experience is a past data. The experience is a past data. This is the machine learning. What is the example of machine learning? Here first we can create the one ML model in the definition just like a fruits already seen in the previous slide. Okay, in this get the some feature extraction. Not only feature extraction, we are also perform the classification. In these features and attributes can be categorized the each fruit. It can be create the blueprint. What the features are there? Simply feature extraction means here what is the size of the fruit, what is the color of the fruit and what is the shape of the fruit. These are the different features. Okay, based on these feature extractions and classification, the machine learning will be develop the models. See this example. We are giving the input as a banana, orange, apple. What are the features are under the input? These are the features. Features will be extracted. Not only features will be extracted and also classifying. After classifying can get the output. That is the machine learning. Coming to the deep learning. Deep learning is a subset of machine learning. The main aim of the machine learning is to imitate the human brains. In the deep learning is called as we are discussing about the neurons. In that neurons can be available in that our human brain. In the human brain by using the mathematical equations. The human brain is consist of billions of neurons that can be communicate with the each and other. This is in our mind. This is the one neuron. This is the one neuron. These are the different neurons are there. In that our mind, so many neurons are available in that our brain. Each neuron will be connected to each other. Each neuron will be connected to the each neuron will be connected to the each other, and it can be enabled to human to see and think and make the decision. The features from the input data is taken as automatically extracted. See this diagram. This is the human brain. Then what is the definition of deep learning? The deep learning is imitating the human brain. The human brain is consist of number of neurons. This is the neurons. This is the neurons. These are the given to the input data is collected from the automatically. So each neuron will be connected to each other and give the output. In the deep learning concept, there is a three types of layers are there. What are the three types of layers is input layer, hidden layer and output layer. 3 types of layers are available in the deep learning. See this one of the example in the deep learning. Here the images will be processed through the different layers of neural network, that is called as a DL model, deep learning model. Each network layer will be define the specific features of the images like shape of the fruit, size of the fruit and color of the fruit. You can see this, observe this diagram. Input, we are giving the input like a banana, orange, apple. What are the features will be extracted? What are the features in the input? Size of the fruit, color of the fruit and shape of the fruit. That is the input. Here can extract the features as well as classification. Extract the features as well as classification. Here they see this red color is the input color, input layer, that is the apple. Yellow color is a different. This one is the another one. This is the hidden layer. The hidden layer having the one or more hidden layers. The neural network having the one or more hidden layers. And finally you can get the output. Coming to the data science. The data science is a science that can be aims the gaining the useful information from the data. Useful information from the data. The data science can be help the companies make the better decisions. For suppose the bank can be analyze the customer data and identify the which customers having the high credit score and tailored products or services to meet their needs. That is the data science. Coming to the difference between the machine learning and deep learning. With the differentiate the deep learning and machine learning techniques in that ability to extract the features automatically. In the machine learning concept, can extract the features and classification. In the deep learning having the, you can extract the features as well as classification. What is the differentiate? The first differentiate is select the model to train and manually perform the feature extraction. While coming to the deep learning process, select the architecture of the network and features are automatically extracting by feeding the training data. The training data is called as a, the data will be given in the form of images along with the target class, that is the label. See this diagram, this is the machine learning. The features are extracted to the manual feature extractions and perform the classification separately. Coming to the deep learning concept, this the cat is there, can apply the convolution neural networks and learning the some features. The features can be extracted from the automatically and predict the whether the image is cat or dog or house. We are here also same. We are giving the input is on cat, can classify the based on the labels, whether the image is cat, the image is a dog, the image is mouse. That is the difference. So up to now, this is the introduction about the machine learning. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.